Again, welcome. It's the Claigan webinar on the new EU and US PFAS restrictions. There's a detailed agenda this morning. We had a bit of a discontinuity this morning where we had a power loss, which created a discontinuity in the middle of the webinar, and I apologize for that. Live and learn. Definitely my language at the time was spectacular off camera. If there was a sailor in the room with me, he probably would have said, tone it down a bit, mate. So that was a bit of a surprise. But otherwise, it's pretty good details. I'm gonna go over everything again now. So hopefully this one doesn't have any discontinuities in the middle of it. But I'm gonna talk about PFAS regulation globally at a very high level. And then, as much as we're talking about these perfluoroalkyl substances, let's talk about fluoropolymers and a typical electronic product. So why is this tangible? I'm talking about electronics and to a lesser extent industrial and medical devices and where we actually see them, and it may surprise you a bit. And then I'm going to summarize the global PFAS restrictions, and then I'm going to talk about the current PFOA and longer, the PFOA family restrictions that are in place today, the newer ones appearing in 10 days, and then a much longer discussion on the new proposed REACH PFAS restrictions, a proposed version where it's at today, what's in it. Then I'm going to talk about some of the US ones, in particular Prop 65. I'm actually going to have a little update on Maine's reporting, which is not a restriction, but it just appeared yesterday, so I've added it in. And then I go back to talk about PFAS's use in electronics. We're a test laboratory and a consultancy. We do a tremendous amount of lab testing. We're probably the highest volume PFAS test lab for physical products in North America. We have tremendous data, and where we're seeing the PFAS may surprise people, especially in electronics. Then how do you find yours? Like, how do you do this? How are you gonna do your restrictions? How are you gonna do your reporting? So how it's done, and then a bit of Q&A. So globally, this map has most of the product level restricted materials compliance requirements worldwide. The ones highlighted in light blue and baby blue are PFAS, have PFAS elements, whether they're PFAS completely or there's some PFAS elements to them. They're all in there. And there's a lot more perfluoroalkyl substance regulation. Perfluoral means basically, it's the simplest structure. It's a polyfluoral, but that's hard to explain. Perfluoral, so fluorinated is F, as fluorine. Alkyl is a fancy way of saying carbon in the chemistry. So fluoroalkyl is fluorocarbon substance. And the fluorocarbons have incredible uses because the F-fluorine and the carbon together, basically when you fully fluorinate a carbon, it has no surface charge, which, okay, you're like, what does that mean? No surface charge means two things. A, it's repellent to water. Water is a very charged particle. The oxygen is so much bigger than the little hydrogens. The oxygen sucks the electrons away from the hydrogens, surrounds itself with electrons, which makes it very negative. And the hydrogens who have lost their electrons to the much bigger oxygen are very positive. So it's very polar. When it runs into a no electric charge system like carbon fluorine, it has no attachment, it bounces. It's extremely water repellent. It's also so low charge that it's also repellent to oils. So it's also oil repellent, which means it's oil, stain, and smell repellent. It's also no surface charge, there's no friction. So if you take, when you're driving a car and if your brake pads rub down into the point where you're at metal and metal touches, the friction is, well, painful to hear and quite traumatic. That's because metal is a very charged surface, and two metals come in contact and they try to move, they stick, extremely high friction, very problematic. That's because they're very charged surface. Chlorinated fluorines, fluorocarbons have no surface charge. That means there's nothing to attach them. They're basically frictionless or very close. So you have this water repellent, stain repellent, frictionless surfaces. So they're really, really handy. And the fluoroalkyl is fluorine carbon. Alkyl is a fancy chemistry way of saying carbon chain. There's lots of regulations coming up, not just this one, but the bolded ones are some of the up and coming. Maine PFAS reporting, I'm going to talk about the very significant LCPFAC ban, also called LCPFCA ban in the EU. It's PFOA and longer. PFOA is already banned, but the longer versions are banned as of the 25th of February 2023, so 10 days. And then it kicks in a little bit later for medical. Actually should be July, not February on the far right. I'll fix that later. It's also got a tremendous amount of legal action. So PFAS has really been moved along by A, the legal action, but B, the political element to it. To the point where Mark Ruffalo plays the Incredible Hulk in the Avengers, did the movie Dark Waters, that created incredible tension. We've seen PFAS jokes on Simpsons recently. There's a tremendous political element to it without people really understanding. There are a lot of lawsuits. Almost all of them are related to factories, which may or may not have allowed some of the non-polymer fluoros to get in the water supply. And PFOA itself is dangerous in high concentrations because it's a surfactant. And like other surfactants, like your laundry detergent, if it gets into your kidneys, it affects the protein surfactant, which processes bacteria in your kidneys and it creates kidney damage, possibly kidney cancer. The fluoropolymers don't do that. It's some of the non-polymer surfactants. Also, a lot more Prop 65 PFAS notifications, a lot more prosecutions there. Now, I'll talk a little bit about the Prop 65. It's got a tremendous public element to the I expect that 3M is pulling out of the business, retiring. It's a fairly profitable business other than the fact they have lawsuits from legacy factories, and they're blamed for everything. Even though most PFAS in water supplies is really from cosmetics, they're blamed for everything. So why do we care about fluoropolymers or PFAS? So when you use it, you don't use PFAS, use the fluoropolymers, which are one aspect of PFAS. The reason you're using them is in the form of fluoropolymers. The useful thing in your product, unless you're making liquids or chemicals, are fluoropolymers. PFOA is not a fluoropolymer. It's regulated. It is a manufacturing aid non-polymer that can be present as a contaminant or trace residual in a fluoropolymer. But what you're actually using is not PFOA. You're using a fluoropolymer like PTFE, Teflon, FKM, Viton, PVDF, a Kynar, and that kind of thing. So you take a product like this. By the way, this product, I just took the picture off the web. The data here is actually for similar enough product, but I threw one on here. So if this is somebody's product, it's really just copied from the internet as an example. It might have a couple solid fluoropolymer parts. We see that, especially in electrical connectors. We see solid PTFE often enough. Might have a fluoroelastomer, less likely for this kind of product, but we can see Viton, fluoroelastomer. We see it a lot more in industrial or laboratory products or medical devices, especially laboratory products. We see Viton all the time because it's very chemical resistant. Cheaper products, we see nitrile, which is not as chemically resistant. But the most common one in a product like this, fluoropolymer mold release agent. So it's a mold, like your muffin tins. So when you make muffins, if you just put the muffin mix straight into the tins and cooked it, it would stick and you'd be sitting there gouging it out. And the last thing you want on the products that you're molding is gouges and rips and stuff like that. So if you had a muffin, you'd either put a muffin liner, paper liner or silicone liner in there, or you put a nonstick coating, maybe butter, maybe Pam, maybe something like that, a nonstick coating. So your muffin releases from the mold, the muffin tin. It's the same thing as all your molded parts. You'd be amazed if you take a product like the one here, how many molded parts there are. It would stick into the mold unless they put out a release agent. And the most effective one for polyurethane foam and for polycarbonate ABS blends is a fluoropolymer. It's a fluorosulfonate polymer normally, and it's basically the nonstick coating in the mold. So it's not intentionally added to your product. There's no use in your product, but it's made in manufacturing. It's used in manufacturing a product like this, 3 to 5 parts that have a mold release agent on it. So fabric, which is not here, like the textile carrying case, also has it often as a side chain fluoroacrylate polymer. And I'll explain that a little bit later. So like when you have a fluoro on your jacket, it's not Teflon powder, not Teflon. It's a side chain. It's an acrylic, like your contact lenses, with side chains of PFAS coming out of it. And so the outside world sees these almost hairs of carbon fluorines, which have no surface charge, and that's why your jacket's waterproof and stain proof. Silicone can make it partially waterproof. It's not as good, but it's not oil resistant at all. If you have any silicone cookware, you probably noticed that they suck up flavors and smells because they're not oil resistant, as opposed to fluoropolymer, which is very much so. Also, those wires and cables, it's very common for very flexible wire and cable to have fluoropolymer coatings on the inner wires and on any paper strain relief coming down the middle, because if you don't put a frictionless surface in there, it starts to bind and the cable wears very quickly. So it's very common in a wire situation like that to find fluoropolymer coatings. And if this is a medical device or a laboratory product or something like that, especially with fluids, it'll double this number. We'll see the medical devices all the time. The molded parts, the fluoropolymer release agent makes the quality of the part more consistent, better, nothing sticks, no burrs, they're perfect parts. There's a really good reason why they use fluoropolymer release agents in medical devices all the time. Plus, PTFE is non-stick. There's a lot of invasive medical devices that don't want to stick to the thing they're going through. And so PTFE is really good for that. It's also really good in situations where you have rotation or movement as a bearing. It's basically a frictionless surface. Incredibly useful, completely inert. Fluoropolymers, by and large, are extremely inert, don't affect anything. What they get the bad rap for is a manufacturing aid that can be used for them that has sometimes gone into rivers and caused problems that affects your kidneys. The fluoropolymer doesn't do anything. There'll be a lot of mom chat groups about their Teflon coating. That's probably the most inert, safe thing you can imagine. They can talk about it, if it gets hot, it has to get to 900 degrees Fahrenheit before bad things happen to it. So if something's getting 900 degrees Fahrenheit in your house, you have other problems. But whatever, I think about safe or not, we'll see how that comes out. It doesn't really matter because what is regulated is what is regulated. Though whether it's really dangerous will come up a lot, and we'll talk about the Europe. Industrial products can have more or less. The funny thing is they either use a lot of them or not. Metal, very rarely, except for little like mesh films. They don't use fluoropolymers very often. Mesh films use fluoropolymer coatings often enough. Industrial part might have some Teflon parts or connectors. Where it's most likely to have is things like PTFE tape. PTFE tape is incredibly useful for liquids and gases. PTFE tape is actually really kind of cool because it's the exact same thing as a solid PTFE part. So you're like, well, I have a PTFE, connector. It's hard, it's rigid. That's totally different than my tape. No, they're actually the same thing. Kind of funny. So what they do is to make the solid part, they put powder in a mold. So molds come up again. And then they cure it, say 400 degrees Celsius, and it melts into a solid PTFE part. And that's what you use. So to make PTFE tape, it's almost the same. Instead, you make a huge molded cylinder, thick cylinder. You put the powder in, you heat it up to 400 degrees, and you create the solid, thick cylinder. Then you turn it on its side, and you do skiving. Skiving is you basically take a blade into the cylinder, and as the cylinder turns, it skives, peels a very thin layer off, and that's PTFE tape. And then you add your adhesive, and then you put it onto its release paper, and you wind it up on another side. And that's PTFE tape. It's actually skived, peeled from a solid cylinder. It's kind of neat. So it's really PTFE powder fused. PTFE grease, which is PTFE powder, again, suspended in silicone oil or mineral oil, really common lubricant. They might have some mold release agents, especially in the plastic connectors. If they have wiring and anything that needs to bend at all, it often is a fluoropolymer coating on the inside of the wiring. They might have some fluoroelastomers. If it's touching anything that's chemically, it won't be using nitrile, you'll be using the Viton. You'll be using FKM, which is the fluoroelastomer. Nitrile rubber is reactive with a bunch of chemicals. FKM generally is not. So we'll see a variety of fluoroelastomers. So industrial product might not have those. So it can be lower or more. It's actually kind of funny. It's one way or another, depending on what it's doing. The more it touches liquids and chemicals, the more it uses. The more plastic it has, the more it generally uses too. So today I'm focusing on restrictions, not reporting. I will have a little deviation on Maine on reporting because the rules changed yesterday. Main restrictions today are in the EU. They're on the PFOA. Oh, by the way, is octa, and longer, nona, deca. So PFOA is 8 carbons, 8 octa, PFNA 9, and PFDA 10, and so on and so forth are what's being regulated. Today, PFOA is banned in the EU at 25 parts per billion. A little bit long, still a little more time until 2025 for medically invasive devices. Prop 65, it's regulated with the usual Prop 65 warning. Canada is banning PFOA and longer, so same things as the EU, but likely instead of 25 parts per billion, 1 ppm, which will be pretty irrelevant for most physical products. PFOA is a surfactant contaminant for the manufacturing process in general, and 1 ppm is not really a big deal. Vietnam is going to do roughly the same thing. They basically have the EU law written to 1 ppm. The EU REACH restriction that is in an end game consultation. It's called Have Your Say. It's basically done. It's about to be published. It has to go through a consumer consultation, which generally nothing ever happens from, and it gets published. That's PFHXS, but fluorohex 6. Sulfonate, it's a different family. I'm going to talk about the difference between carboxylates, PFOA, and sulfonates like PFHXS or PFOS. It's being banned in under REACH, and the ban will probably be published in the next month or two, going to effect probably end of 2025. And then one of the bigger topics is this proposed, this is the strictest it's going to get, EU REACH PFAS restriction. What's in the proposal is a start. There's a lot of water to go under the bridge still. And Maine has a general PFAS ban in 2030, but it's really a stake in the ground. It's basically, if nothing else happens, they ban it in 2030. However, the feds create a law, they follow the feds' rule. If the other states create a law, they'll follow them. If there is any, however, nobody else does anything and there's uses for it needed, you can submit the uses. So it's kind of funny. It's like 2030 ban unless somebody does something or has a justification. So if you have a reason not to, or if you're like, well, it's a pain in the butt to lobby Maine, let's send some stuff to Maine, but let's make the federal rules work out. The Maine law is written to follow federal rules. Kind of neat. There's also some sector-specific stuff. California, food contact packaging is banned all PFASs. PFAS are banned in juvenile products. Maine, PFAS are banned in carpets. The EU PFOS, which is another sulfonate, it's banned at 1,000 ppm, but it's pretty irrelevant in physical products because it never ends up being that concentration. In physical products, it might be a couple ppm at most. So what do we do? Today, PFOA is banned in the EU at 25 parts per billion, or there's a range of chemicals that can degrade into PFOA, and I'll show them later, and you'll get a walk down chemistry lane, and you'll be like, I'm just gonna fade out right now. Just take it that there's PFOA, and I'll show that one, is banned at 25 parts per billion in articles, and there are a number of substances that are very similar that degrade into PFOA. They're all banned. They're all non-polymer PFAS. They're all carboxylate family. In the near term, they're also banning the longer versions of PFOA. Sometimes called long-chain perfluoroalkyl carboxylates, also called long-chain perfluorocarboxylic acids. So LCPFAC and LCPFCA are the same thing. It's just different ways to say the same thing. Long chain is for carboxylates, 8 carbons or longer. For sulfonates, it's 7 or longer. Why they're different, I don't know. It just is. Perfluoro, so this is usual fluorinated. Alkyl, fluorinated carbon. Carboxylate, they have a carboxylate group at the end. They're also called long chain, okay, LC, perfluoroalkyl. That's PF. The A gets jammed in there. Carboxylic acids, LCPFCA. They're all the same thing, the same chemicals. So they're being banned at 25 parts per billion as of February 25th, 2023. So PFOA is 8. This starts banning Nona, 9, Deca, 10, and larger. It's a very significant ban. It kicks in 10 days. So, and if you don't even know where your fluoropolymers are today, this is going to be exciting. By the way, all of these chemicals only exist inside fluoropolymers. So in a physical product, if you have a physical product, you're using a fluoropolymer. It may have residuals of PFOA or LCPFAC, PFOA longer, in it, but they're not what you're intentionally using. You're using a fluoropolymer that can have this as a residual from the manufacturing process, or in other cases, degradation product. It's banned February 25th, 2023. If you don't even know where your fluoropolymers are right now, yeah, you're not gonna make this one. Medical device a bit longer, 2025. Same date as their PFOA restriction. So you basically can't have PFOA or longer in a component above the regulated limit. There's no specific due diligence or paperwork requirement. However, if you've done the work, especially testing is the best due diligence from a national authority point of view, there's really no penalty if you make a mistake, because the amount of PFOA that you have in your product will be trivial, so they can't really punish you for the amount of human damage. They can only punish you for not doing the work. So as long as you've done the work, like a test report, which is one of the best ways to do the work, at least for represented products, you'll be fine. It's a very difficult one because the supply chain is going to be this side of useless because it's a contaminant, and it wouldn't be declared in any full material declaration ever, just so you know. By the way, if you ask for, we got this a lot, hey, do you have a full list of PFAS chemicals? It doesn't matter. It has nothing to do with anything. You're like, what do you mean? Well, the ones in this family are very specific, and the general PFAS has polymers in it. Polymers use a very different naming convention than you're not used to. Remember all the stuff you had in high school where you did like how you name an alkane or an alkyne or an aldehyde or a ketone? Yeah, that doesn't apply to polymers. They're totally different. Yeah, you're in for a new world. If somebody gives a big long list of cast numbers, it's like a lot of those chemicals can be called 8 different things. It's not very helpful. The key thing is, do you have fluorine? That's the starting point. You're not going to find any of these on the safety data sheet. They're below a declarable level. So it's just fluoropolymers, and most fluoropolymers do not have a cast number, just to make life exciting for you. So the restriction, by the way, I'm talking about I call it the long chain perfluoroalkyl carboxylate. It also is called long chain perfluorocarboxylic acid, just to make life difficult. It's C9 to C14 PFCA, so it's perfluorocarboxylic acids. That's what it is. It's just naming, as I said before, there are like 8 different names for a lot of these complicated organic substances. I think perfluoroalkyl carboxylates is more accurate than perfluorocarboxylic acids, but it's really tomato. So these are restricted as of February 25th, 2023, with a little bit farther for implantable and invasive medical devices. So what's the PFAS? It has one of the things on the left or the right. It's got a fully fluorinated carbon, either with 2 fluorines and 2 carbons. So by the way, when you see a dash going up the side with nothing attached, that's a carbon. It has to be attached to another carbon, or it's 3 fluorines. And that's what it is. Now, if one of those fluorines is a chlorine, it doesn't count. However, if you have a carbon, another one's elements later in the same molecule, it does. There's a number of chemicals, PFASs, we encounter, especially as mold release agents, that have elements that are fully fluorinated like this, and elements that have chlorine on them, interspersed on the same polymer. Polymer chemistry is exciting. It's still PFAS because it at least has to have one of these once, and then you're a PFAS. It's the easiest way to explain it. And talk about huge cast numbers. You're trying to do data gathering by computer by cast number. That's cute. That's not how it works. These are not like what you're used to. And what you learn in high school and early university about chemical naming will not do you any good come polymer time. So there's 2 different major kinds. All that matters is the polymer version and the non-polymer. Polymers are repeating chains, and there isn't necessarily one way they have to repeat. They have many, many, many options, tons of copolymers, very complicated stuff, but they're repeating chains, and that thing you're using on your product is a polymer. When you're using a PFAS, whatever it is in your product, it's a polymer version, because the other ones are water soluble. Non-polymer ones are the ones that are currently restricted, PFOA or 6,2-FTOH, which is a fluorotelmer. 6,2-FTOH is 6 carbon fluorines, 2 carbon hydrogens, OH. It degrades into PFOA and PFOA is banned at 25 parts per billion. 6,2-FTOH, which is a fluorotelmer, is banned at 260. It's a fluorotelmer. The one above it is a fluoroacrylate. It's very exciting. Actually, it isn't really 6,2-FTCA. Different chemical. I'll get that one fixed. So the key major groups in the non-polymer are the carboxylic acids, which PFCA or carboxylates, depending how you want to say them, perfluorinated carboxylates, PFACs or PFCAs, same thing, tomato, and the sulfonics. They have sulfonates. And the difference between them is the terminal group. Is carboxylic acids, the carbon double bond oxygen, and then an O, could be H. I'll explain that. It doesn't have to be an H. And the sulfonates, which is the sulfur, the 2 double bond oxygens, O, could be an H, doesn't have to be. The funny thing about either chemical is none of these are what's regulated. What's regulated is once it hit water, that hydrogen pops off and it becomes O- on both sides. So that hydrogen could be a sodium, and I'll show later, hydrogen, potassium. There are about 20 different salts. If you're getting into all the different cast numbers, have fun, because it's every single salt of this, but what's actually in your product, when it's integrated into something else, it no longer has the salt attached. But what makes them so useful, these ones, is they're a surfactant. They have a polar end and a non-polar end. So it's like your laundry detergent, which, by the way, is a surfactant. So they have one end where the hydrogen pops off, becomes O-, and that's very polar. Water, as I mentioned earlier, is very polar, like. Chemicals are bigots, it's like. And water, with its very negative side and very positive side, the positive side really likes the very negative O- when hydrogen pops off. Very polar, loves water. The other side, as I mentioned earlier, carbon fluorine has no charge. It's inert, and so very nonpolar, and it's quite conducive to fluorinated oils, like TFE to make PTFE, and it's an incredible surfactant for making fluoropolymers, and that's why it's used. And so when we get it, PFOA, in your PTFE polymer, it's trace 100 parts per billion because it's residual surfactant for making PTFE. It has no use whatsoever, the PTFE. All it does is surfactant. It helps the reaction between the TFE monomer and potassium persulfonate to create polymerized repeating chain PTFE. Lots of great chemistry, but basically the short form is this chemical as a dissolved form is really useful for manufacturing fluoropolymers, but it's not part of the fluoropolymer itself. When it's in your product, it's a residual in the fluoropolymer you're using. So you're not using PFOA, you're using a fluoropolymer which may have used PFOA in the manufacturing process. So from a Maine perspective, your PTFE is what's reportable. It's what you intend to use, your fluoropolymer. The PFOA residual is not intended. It has no use in the final polymer and is not reportable, but it is still banned in the EU. So the carboxylic acid group is PFOA family. I probably want to do a lot of chemistry, but I just want to explain why this is really that complicated. So nomenclature is an incredibly difficult problem in all of this. That is a carboxylate group, that thing I circled. Don't worry, there won't be a test later. The hydrogen doesn't have to be hydrogen because when we test for it, it's literally once it hits water, the hydrogen leaves and it becomes O-, which I should have a picture here. That hydrogen could be sodium, it could be potassium, it could be ammonium. It doesn't matter because once it hits water, it becomes O-. And it could be linear, kind of a straight line. You might look like that's not a very straight line. That's kind of a little jagged. That's called linear. It's all one direction. So PFNA is in the bottom. It's 9 again. Or branched. It can be sticking out the funny sides, and those are used at times. Those are carboxylates. It's the PFOA, all of these and longer are banned in EU as of 10 days from now. Also banned are the stuff that degrades into it. So this is a fluorotelmer. It's used to make other things. It's, again, not intended to be in the final product. It's got 2 carbon hydrogens. It's really useful for creating, this is actually used to create other polymers, not as much as this. This is the most used one. It's a fluoroacrylate. It's for making coatings, acrylic coatings with side chain PFAS. There's a whole, one of my previous webinars, I talk about side chain PFAS. Literally, it's acrylic, like contact lens material, or methyl methacrylate, on the surface of your fabric. This is the use in fabric, and it's the acrylic like this, and then side chains sticking out of it are carbon fluorines like this, PFASs. And by sticking it out as like hairs, very microscopic hairs, the carbon fluorine presents its no charge side to the outside world, and that creates the water repellency and oil repellency of your jacket. But this is a monomer to create, so methyl methacrylate, for example, is a very common acrylic coating. So you're making acrylic coatings with these PFAS sticking out of it. So it's banned at 260 parts per billion because it degrades into PFOA. So it's PFOA is banned and longer, and the stuff that degrades into them, like this. And this is why we see a problem with the fabric, and why they have trace PFOA sometimes, is some of this chemical during the manufacturing process, when it was polymerized to make this coating, some of it fell apart at one of the oxygen bonds, and you ended up with a tiny bit of PFOA. So of no use to it. It doesn't have to be there, and they can use shorter chains. So the newer coatings use shorter chains and don't have PFOA anymore. But this chemical, if we find it, because it could degrade into PFOA, is also regulated. So this is the current restriction. Again, PFOA is banned at 25 parts per billion, plus this crazy stuff I just showed you that can degrade into PFOA. It's banned at 260 parts per billion. We do see it. We do see fluorotelmers and fluoroacrylates often enough. PFOA is most common, though. In 10 days, February 25th, 2023, the longer versions, Nona, Deca, so on and so forth, are also banned at 25 parts per billion. Now, they don't exist on their own. None of the chemicals I just talked about have any use in a physical product on their own. They're either used as a manufacturing aid to make a fluoropolymer, like PFOA, or they're a degradation product, like we saw from the fluoroacrylates. When you're making the fluoroacrylic coating for your waterproof jacket, they can, some of them can break apart and have some residual PFOA. simple, clear as mud? Probably not. So the key thing is, where do you find these restricted non-polymer PFAS? In polymer ones. They don't have any use on their own. The only reason we find them is they're either a manufacturing aid or an ingredient or a degradation product of the polymer you are intending to use or your supplier is using. So they're using, or you're using, a polymer PFAS. It might have some of those along as an unintentional rider. They're still restricted. So what you want to do is you want to find your polymer PFASs. Once you know your polymer PFASs, you know you're reporting for Maine, but you know where your non-polymer risks are, the PFOA risks are. So that's today and very near term. Meanwhile, the EU on February 7th published their proposed REACH restriction on PFAS. So the EU didn't make it, by the way. The EU published it. It's a technicality. 5 EU member states, the ones that made it, based on a consultation they did separately, Germany and Sweden and such. And everything in it is based on feedback they got during the consultation to themselves. Now they propose this to the EU. It's the broadest proposed restriction ever. It applies to non-polymeric PFOA and polymeric PFAS. This is as strict as it's going to get. Everything from now is going to be scrolled back. There's a lot of lobbying and consultation left. This is the strictest version. It's probably going to be down-tuned somewhat. The restrictions either start 18 months from when it's published, which is not this. This is a proposal. This isn't even a draft of the law. This is a proposal, which eventually will become a draft, which will eventually go through a lot of other steps, which will eventually become a final version, go through another consultation, and be published. And I'll show that timeline in a minute. Then the restrictions start as early as 18 months for mold release agents, to 6.5 years for certain products, to 13.5 years for a number of other segments. Most of the ones at 13.5 years, they can't really justify why they're replacing it. We'll see what happens to these. So it's actually really 18 days from entry into force, 18 months from entry into force, which is 20 days after it's published. Basically, someday when they publish it, the restrictions start 18 months later. So where we are now, this is not the law, this is not the draft, this is not the text, this is a proposal. A proposal will go through a consultation publicly for 6 months. This is where you have to get your digs in. So a lot of your associations have probably been talking about this way more than the LCPFAC restriction I just talked about 2 pages earlier, because that one's a done deal. There's no money in it for them. There's money in it for them now. This lobbying is actually very important, and they actually have a real purpose. But the reason you're hearing so much from your association is because, follow the money, this is where they make their money. Nobody wants to pay their association, but they do have uses. So in this case, they're actually quite useful, and that's why you're hearing so much about it. The restriction that's already in place that hits you in 10 days, you're probably not hearing about as much, but it's far more tangible and more impactful to you at this point in time. So this will go through a consultation. This is where you want your pieces in. 6 months, and then maybe publish the comments in December. I'm also that's going to be a little bit tough. I am slightly skeptical, because the way, and I'll show the proposal, the way it's structured, all the different exemptions and timelines are sector specific. And so different sectors can be focusing a tremendous amount of energy on different elements of it, not the same element. So they're basically going to be fighting 40 to 50 separate battles as part of this, as opposed to fighting 1 or 2 battles. This is going to be a lot for them, because they really set it up that they're going to fight 50 separate battles instead of fighting 1 or 2. Meanwhile, for 1 year, there's going to be a technical review, whether or not this actually makes sense, feasible, is a good idea. One of the things that'll come up is, you know what, the fluoropolymers work a heck of a lot better than the replacements, and they're way safer than the replacements. Silicone is not as water repellent, it is not oil and stain repellent. It's far more much higher friction, it wears down quicker, and it's also full of the SVHCs D4, D5, D6, which are also forever chemicals. So really, you just want to get rid of the PFOA side, which in large concentrations, not small, is a kidney problem. So that's going to be an interesting part of the technical review. Then once they finish all these comments in technical review, maybe they'll have a draft version in September 2024, and I think that's a bit optimistic. Then the Parliament, the Commission, and the Council, 3 elements of government, will horse trade between them. And if they're lucky, that might take about 9 months, maybe May 2025. I think it's going to take longer, especially when they created a structure where they're going to fight 50 battles at once instead of 1 or 2. I'll show why in a moment. And then they'll find the final version, maybe, if everything goes smoothly, which is a bit optimistic, They'll have a final version which goes through the mandatory have your say consultation, maybe around September 2025, published in, say, December 2020, end of 2025, which means the first restrictions 18 months later, about August 2027. And some industries like medically invasive, the earliest restrictions will kick in as 2038. And that's a good one for my kids to worry about. And that's if this is the most optimistic, strictest, fastest way you can go. Since they're fighting 50 separate battles, it's going to be tough. Now, the proposal is two proposals. I love how they always do this. A, ban everything at 25 parts per billion, sure. Or ban PFAS at 25 parts per billion with a large number of longer timelines. So what they're really arguing is proposal two. This is really proposal two. So off the bat, it includes articles and mixtures. So it includes the chemicals you're selling and physical products. Most people hear physical products. So your electronics and your fabric and chairs and all of that's in scope. And they're planning to ban all non-polymeric PFAS, size independent, at 25 parts per billion. I don't understand the 250 parts per billion because they're also non-polymerics. So we'll say 25 parts per billion. I don't think they thought this line through. If it's polymeric, which is what you're using, banning it at 50 parts per million fluorine. It's going to be, that creates an interesting problem, actually, it'll come up later. Out of scope or stuff that's out of scope of reach, pesticides, biocides, pharmaceuticals. Because they're out of scope of the restrictions. They may have reporting requirements, but they're out of scope of the restrictions. And then they say, hey, meanwhile, whether it's non-polymer or polymer, these sectors have longer timelines. And certain polymerization aids, personal protective equipment, which kind of needs the water and stain and chemical repellency, some refrigerants, some cleaning fluids. So these ones are broadly have longer dates. In the 6.5 years, they believe it's quite replaceable, it just takes effort. If it's 13.5 years, they don't know if it's replaceable. And they just threw a 13.5 year number out there, and we'll see where it goes after consultation. So if yours is 13.5 years, they know they're on shaky ground. And every single exemption, by the way, on the right, is because somebody asked for it during the consultation. So if you want one, you have to ask for it in the next 6 months. And you have to justify it. And so there's a huge number of ones saying, hey, we don't know if it's a good idea. Firefighting foams and diagnostic laboratory equipment and a bunch of refrigerants and lubricants for harsh environments, kind of very important calibration samples. Like our lab would be allowed PTFE samples and PFOA samples uses calibration for our test equipment. Kind of makes sense. And then they're also, we're not letting these ones right now, but we're going to talk about it. Textiles for automotive, hard chrome plating, bunch of 3D printing elements, foam blowing agents for 3D, some cultural paper. That's an interesting one. And heat transfer fluids for medical. A lot of the fluoro ethers, the chemical versions, are heat transfer fluids. And membranes for venting of medical devices and semiconductor manufacturing. These are ones they're going to talk about, but actually aren't in here yet. Then for polymers, there's a whole bunch of other longer deadlines. Food contacting, medical implantable, medical tubes and catheters, meter dose inhalers, fuel cells, which I wonder if that actually includes batteries, but it doesn't look like it. Petroleum and mining industry. There's a good reason why they need FK on Viton. Nitrile rubber will dissolve in most chemicals. In the petroleum industry, you really want Viton in those gaskets. People are not very popular, not very fond of gas pipeline leaks. So you really want to be using a chemical that can stand up to it. So they're going to want to talk about these ones. And then there's a bunch of others they're going to say they're going to talk about. Some more on contact lenses, non-stick coating, medical packaging, and a whole bunch of others. There's another whole page of this I seem to have lost. There's a lot of individual lines, and you can go take a look. Earlier, there's a hyperlink to the actual proposal, starting around page 8. You can start wandering through it. Irrespective, even if you have an extension, like medical devices, you will have to report, like Maine, your PFAS information every single year after 18 months from it goes into force. So there's going to be a reporting requirement, even if you're excluded from a restriction. So if you're a medical device and you have 13 years from publication, after 18 months, year and a half, you're going to have to report almost identically to Maine every year. If you also use fluoropolymers on site, even with an exemption, you're going to have a site management plan. They also have a note, if they made stricter legislation like the PFOA stuff, it takes precedence. So this, by the way, is a proposal. It's not the final version. There are a lot of steps to go. There's a consultation, public consultation, and if you have a use that isn't in there, like lithium batteries, the PVDF and the cathode is kind of important to electric cars. Really needs somebody to mention that. You really need to do those 6 months. And as I talked about, there was like industry after industry here. These are separate arguments. When I'm talking to a multinational, they have one division that'll be focusing like on the diagnostic laboratory equipment, while somebody else will be focusing on the foam blowing agents. Totally different, totally unrelated conversations. So in a way they've structured this, they're gonna have 50 different or more arguments ongoing, as opposed to just one. This is going to be overwhelming from a consultation point of view. They're not arguing 1 or 2 points. They're going to be fighting 50 plus separate battles. Not the smartest way to do it. I'm not sure they knew what they're getting into. There's a lot of politics here. Meanwhile, in parallel, there's a fully technical review. And as they go deeper and deeper in the replacements, they're going to go, you know, it's a really bad idea to have a medical device that binds internally in the body. And this thing's inert, and it's kind of important not to stick and not to react with the body. Maybe we should use the safer stuff, which is the fluoropolymers, instead of silicone or something else that'll absorb body fluids, cholesterol, a bunch of other goodness. So again, the earliest we're going to see restrictions if everything happens will be probably August 2027. But we'll see. This is still a proposal. That's the EU side. Now, the US side has a little bit less going on. They have more in the reporting. The restriction side, they do a Prop 65. And Prop 65 got updated end of last year. Well, actually got updated end of 2021. But the way Prop 65 works is an update doesn't take effect until 1 year after it occurs. So they updated the Prop 65 list at the end of 2021. And that means it doesn't impact products manufactured before the end of 2022. Now, the deadlines here, like everything in Prop 65, are based on the date of manufacture. Products manufactured after December 31st, 2022 have to also include PFNA and PFDA. So again, PFOA is 8, PFNA is 8, PFNA is 9, PFDA is 10. They're the long chain before alkyl carboxylates, and PFOS is sulfonates. Now, generally the way Prop 65 works, their concentrations are so low, they're not really a Prop 65 issue unless food contacting or wearable. They see excessive contact. There's already been 26 prosecutions so far, mostly in 2022, all basically in the PFOA and PFOS, because PFNA and PFDA were not prosecutable until this year, 2023, and it's based on the product's date of manufacture. If they bought something in February this year, chances are it was manufactured before December 31st, 2022, and they couldn't prosecute it for PFNA and PFDA. But one of the updates is they've added some of the main long chain carboxylates or carboxylic acids to the Prop 65 list. So PFOA is already there. They added, and they came into effect end of last year, PFNA and PFDA. So like everywhere is PFOA and longer. Plus PFOS, which is rarer. We don't see it very often, actually. As a side note, in the US, this is not a restriction, but Maine has updated their draft reporting rule, and there's a hyperlink here, and it got published yesterday. A whole bunch more details about customs codes, where basically you group products together if they have the same custom code, same PFAS, and they basically have the PF at the same quantity and use. So it's a good reason, a good way to group your products, because they charge you $250 per 3 product families you notify. There's a lot more details and costs, enforcement, notification, and one kind of very important rule is, it's a lot of confusion about this passage. Notifications are required only for products or product components offered for sale or distributed for sale in the state of Maine. Product components that are incorporated into a complex product which are offered or distributed for sale in Maine are not subject to notification, even when the information regarding the product components is provided as part of that product's notification submission. What that means is you make a gasket and it goes into a pump, and the pump is sold in Maine. The pump needs to report the gasket. The gasket doesn't need to report itself, unless you're selling the gasket on the open market in Maine. So if you're only integrated into other people's products sold there, then it's only the final integrator that has to report. There's also some provisions that if the gasket guy is already reporting, the product manufacturer can get a waiver and use the gaskets information, but it's actually more effort than just reporting it, because a lot of your fluoropolymers are going to be repeating same general thing, especially when a lot of the fluoropolymers have one CAS number for a huge family of things. It's actually a lot easier to report most of the time than worrying about, it's really so-and-so's part, and their information is already notified, so we don't have to. Default, the final product manufacturer of the product sold in Maine is the guy who has to report. There are other waivers and fiddly-fiddly you can do, but realistically, it's the final default, the final product manufacturer of what's being sold in Maine. So you make a gasket into a pump, and it's the pump being sold, it's the pump manufacturer. If you sell the gasket separately, you have to also. So it's a bit confusing, and I'm moving back on to restrictions. So what do? Find your PFAS polymers. What you're using is a polymer. What might ends up being in there might be some restricted non-polymers, but what you're actually using is the polymer. And so you need this for reporting in Maine, and you'll need it for the new federal US one coming out probably this year, and the EU one when it appears, reporting requirement. So when you identify the polymer so you can report, awesome, and you know which parts are risk of having non-polymer PFAS. The non-polymer PFAS doesn't exist in physical products unless it's inside a polymer. They have no use on their own. They're mostly water soluble, they're real or a fluid, and they have no real use of their own. Even fluoropolymer lubricants are literally suspended PTFE powder, which is a polymer, inside mineral oil. Simplest method, test fluorine. Key rule, no fluorine, no fluoropolymer. It's that easy. And fluorine doesn't really exist outside of fluoropolymer usage. It's not a very naturally occurring material. So test for your PFAS polymers. And then for restricted non-polymers, test your identified fluoropolymers. And you don't have to repeat it. You really want to do a good sampling to show you've done the work. As long as you've done the work, there's really no penalty for non-perfection. It's hard to penalize you for the amount of PFOA you introduce on the market because you're going to be in the fractions of a microgram. You can only be penalized for not doing the work. So you want to do the work, and a test report's the easiest way to show the work, and it's the fastest and cheapest. But first thing, send us your product. No fluorine, no fluoropolymer. It's that easy. When in doubt, start with the representative one. It works fantastic because your supply chain is not going to be very helpful here. So when in doubt, you have products of any kind, we can fix it. We can give you what you're going to report to Maine or US. This is exactly what you report. This is why. And then we can also give you the restrictions results. So you have the due diligence on the PFOA and similar and longer restrictions. It's really good. It's really effective. And you're going to be shocked where you find them. So I went back to this one. Again, this is just the data is real, but the product here is fictitious. The fluoropolymer mold release agent is everywhere. It's in most polycarbonate parts. It's in every single polyurethane, even if it's just your packaging. You find it in the polyurethane foam. It's basically polyurethane foam. I believe it's really sticky, and it won't release from the mold unless you use a fluoro release agent. And so we get fluoropolymer coatings everywhere on products because of the release agent, because they're molded parts. If you have molded parts, chances are you're going to have fluoropolymers, PFAS, a lot more than you think. You might also be using a few PFAS. You might be using PTFE tape too, some fluoroelastomers. Your cables are going to surprise you and have strain relief. And it's not like they're using PTFE as the cable. They're using it as a coating, which the supplier may or may not know about whatsoever, on the strain relief or the internal wiring. Duster products have a wider range, but they use more PTFE tape and more PTFE grease. They give a lot more or a lot less, depending on what they're doing. And in chemical or fluids related, usually has a lot more, especially the use of Viton, FKM. Biggest, most unexpected ones is polyurethane, is the mold release agents. So again, you have your muffin tin. Your muffins would stick to your muffin tin unless you had a cup in between or you had a non-stick coating. So you often butter or otherwise your muffin tin, so your muffin comes off. Otherwise, it rips to shreds. It's the same as your polyurethane foam. It's going to rip to shreds unless it's a mold release agent. Virtually every single polyurethane foam we test, the outside has residual of the mold release, fluoro mold release agent. Polycarbonate molded parts are very similar for whatever reason. It's very effective. I mean, if you want a high quality molded part, putting a fluoropolymer release agent at a very thin level, it's usually a fluoropolymer sulfonic in the PFBS family, is extremely useful. PFBS is 4. One of the neat mnemonics in this space is monkeys eat peanut butter. Methyl is 1, monkeys. Ethyl is 2, eat. Propyl is 3, peanut. Butyl is 4, butter. Monkeys eat peanut butter. So easy way to remember some of the smaller ones, PFBS. It's a very short chain sulfonate. It's normally inside these as a residual of these fluoropolymers, but they're generally a sulfonic fluoropolymer. If you look up one of the manufacturers like Dakin, and you look up Day-Free, D-A-I-F-R-E-E, you look up it says SDS, you'll see fluoropolymer, no cast number. It's very exciting. Polymer chemistry is lots of fun. So we see all the time as a mold release agent. above 50 ppm on polyurethane foam and polycarbonate molded parts or polycarbonate ABS blend. We also see it inside the cables of strain relief. Anything flexible, you put a little coating. Usually it's an emulsion PVDF. Fluoro, it's basically PVDS is emulsified in some solvents like DMAC. You put it on, you let it dry, and it leaves a thin fluoro PVDF coating on it. And you now have these frictionless wires or strain relief, and then your cable doesn't bind, and it lasts a lot longer. It's very thin, very useful, very common. Chances of you having it on your material declarations, or especially anybody tried full material declarations, they're not declarable under full material declaration. So you're gonna have to start again. Mold release agents, extremely common in electronics and medical devices in particular, because they have high quality standards. A good fluorosulfonate polymer is excellent mold release. It works really well. It's great for releasing the part. Also, if you have polyurethane foam, whether it's your packaging or inside your product, most LCD screens have a polyurethane foam around the edge where it seals, a bit of shock resistance. It's almost always a mold release coated. Basically, the mold goes in, had a fluoro release agent, and it sticks to the polyurethane foam. Now, the neat thing about it, it's not in the scope of Maine PFAS reporting because it's not intentional. It's not supposed to be. There's no function to your product. It's function in manufacturing, but your product, your multimeter, has no use of the multimeter. It's literally a manufacturing step, so it's not intentionally added. It's also very low risk of PFOA and LC-PFAC. It doesn't use that material set. It will have sulfonates, which are like PFOS family, especially PFBS, and PFBS is a reach SVHC also, but it's at a concentration well below a normal SVHC concentration level. And it would be banned. These mold release agents, the way the EU PFAS restriction structure today, they would be banned. And supplier data basically won't identify this. It's a manufacturing step, not part of the part. So none of the data you have today or likely in the future will identify it. So it's very exciting. Again, lots of PFAS stuff all over the world. Some just reporting, a lot of restrictions, more in the PFOA side of things. So what to do? Remember, no fluorine, no fluoropolymer. Just test it. Just talk to us. When in doubt, just get a quote. This is exactly how we do it. We're actually really good at this, and it'll make your life easy. And when you get to the polymer chemistry, it's not fun for a lot of people. I find it challenging, and I think I'm a pretty fair chemist by now, especially in this sector. It's exciting. So basically we can create the field. This is what you're gonna report to Maine. You can understand all of it, and we'll help you, because when you talk to supplier, you're gonna say, hey, it's this. If you want to change it or see if there's replacements, you may or may not have to replace it, but you know where your risks are, and we can handle it and for you. It's really good. Also, your Maine reporting, even with exemption, your clock is ticking. You only have about 4 months left. You really have to get on this. And you're going to be shocked where you have stuff. So test for the PFAS polymers, and then for the restricted non-polymer PFOA, all you have to do is test a good representative number of the actual fluoropolymers. You don't have to worry about every part. You only have to worry about the ones that have fluoropolymers on it. And we have a good rules internally about which substance can actually have the PFOA and which ones cannot. So if we identify them properly off the bat, we know there's some you don't even have to test because of their concentration and makeup. They won't have PFOA. They're not conducive to it. So again, everybody who registered will receive a copy of the slides. If you have any questions, feel free to submit it to the control panel, and I'll try to get to as many as possible. If I don't get to them, just reach out. And when in doubt, just reach out in general. We like talking about this sort of thing. I apologize to anybody else speaking very quickly because I was. The recording, you can, when it comes out in a day or two, you can slow it down. You also have the slides. You can also ask me questions now and later. One of the reasons I was going quickly is you guys can get kind of bored with stuff you've seen a lot. So the idea here is, and I'm not only a limited amount of repetition, you won't necessarily catch everything here, even if I slow down. But the main thing is, one of the most important rules of restricted materials compliance is the things you're most likely to be non-compliant for are the things you didn't know about. At least if identify something exists or you have to look into it, your chance of being compliant to it increases significantly. So it may or may not make full sense right now, but at least if I mention the topic, you'll have a good starting point of which way to go. Would a PFAS mold release be considered intentionally added? That was a great question right off the bat. He actually jumped ahead of where I was going to be. Not normally, no, because it intentionally added normally has to have a function in your product. The mold release has no function in your product. It does have a manufacturing function, but not it's not intentionally added because it has no function in your product. So for Maine, it would not be reportable at this point in time. Where is PFAS most likely found? In IT telecom, like a server. Servers generally have less of it. It depends if they have flexible things like wiring the fans and the power cords and power supplies. Those parts can have it. If you have coax, which is less likely in a server, the coax, the center core of a coax is PTFE. That's pretty normal. Otherwise, it's usually the muffling, the polyurethane foam. And if you have any molded parts, which are fewer in a server, they can have it. But it's often the polyurethane foam. If you have it there for heat or vibration or anything like that, polyurethane foam will often have it. And at the very least, some of your LCD screens will have it behind it for shock absorption, as will buttons. Plus, your packaging in your box might have polyurethane foam. Polyethylene foam, closed cell, generally won't, but polyurethane does. Maine PFAS require notification as of the 1st of January 2023. Yes, unless you apply for an exemption. If you haven't, ask us and we'll show you how to do it. And then you have another 6 months or so. You have 6 months from the date of application. So it's not 6 months from January 1st, it's from the date you got the exemption. So when in doubt, there are about 1,000 companies that got an exemption. We can help you, but it's the reporting requirement's Jan 1st. Right now, there's no system to do it in. You have to email it to them. However, if you need one exemption, it's easy to get an exemption for 6 months, and we can help you with that. But that means for a lot of people, they only have about 4 months left. Do you understand, Claigan, that non-polymer PFAS is currently banned? Polymer PFAS would ban in the future, sort of. The PFOA and longer are banned in the EU, especially as February 25th, basically the whole gamut of PFOA and longer, but not the sulfonates. They're not banned. PFHXS, one sulfonate, will be banned in about a year and a half. It's not very common though. The polymer ones will likely be banned in the future, but it's gonna be so sector specific. And to do that, they're gonna have to fight about 50 different battles, and we'll see where that goes. The earliest any of the polymers will be banned in the EU will be middle to late 2027, probably longer. Is the EU ban is a blanket PFAS ban for manufacturing use, or only when trace amounts can be found in the final product? It is for non-polymer like PFOA. It's a ban at 25 parts per billion, which is basically can't be there. For fluoropolymers, it's 50 ppm fluorine, which is basically can't be there. However, there's going to be exclusions for different market segments. There's real uses for it, but they're all segment. Like I said, they're going to fight 50 different battles of each market segment. Hey, you can use it for this. Hey, you can use it for that. As opposed to saying, that's the problem. They try to ban it broadly, and then basically every single use of it is going to try to get an exemption. So it's kind of a little fiddly. Will your slides be shared at the end of the presentation? Yes. So everybody who registered will receive a copy of the slides after I make one fix today. There's a samesies in there instead of same. Everybody registered will receive a copy. There will also be a recording of this version, not this morning's, which had an interesting discontinuity when I lost power. That was exciting. And thanks again. The number of attendees today is in the 500 range, which is wonderful. Leaving a couple hundred on the hook when I lost power this morning was a bit of an accident. I feel bad about that. Any comments on PFAS presence on printed circuit board? Very limited. It can be, but PCBAs generally have very little. And once they do, it's hard to get at. A coax cable will have it. If for some reason you have some polycarbonate molded parts on it, they'll often have it. If you have polyurethane foam cushioning it, sure. But generally, it'd be limited to the wires coming out of it, where some of the wires, if they have a flexible situation, may be fluoro-coated for low friction. But generally, even those wires are not normally in a friction situation. You're more likely to see that in a cable than you are to see in hookup wires. So PCBAs, we don't generally, I think it's extremely rare actually for us to see PFASs on a circuit board. Earlier time I mentioned Prop 65 labeling in 2025. Oh, so Prop 65, there's my chart at the start. There are ones with solid lines, which are firm deadlines. There are ones with dotted lines, the projection. So Prop 65, they had a 2-year process where they tried to change the Prop 65 labeling, and they missed the deadline. And if they restarted now, the earliest you'll see new labeling requirements, we have to name the chemical, is end of 2025. So my chart at the start has a dotted line because that's the earliest the new warnings could occur, but they don't seem to be meeting those deadlines. So that's going to be pushed out. So this is new Prop 65 warnings. as early as the end of 2025, but that would be optimistically quick on their part. Is a coating considered polymer or non-polymer? It's almost always polymer. It can exist, the coatings can exist in many different forms in the coating. They could be the side chains, which are the like fabric, it's acrylic with PFAS is attached and sticking out the side of the polymer. They're called side chain. It's a really funky phenomenon. It could be a salt on metal. It's PTFE powder that's powder coated on and heated and fused into actual Teflon. And that's Teflon on metal. On plastics like wires, it'll often be PVDF, which is very similar to PTFE, but there's a chemical difference, dissolved into an aprotic nonpolar solvent like DMAC. Think of it as a solvent for advanced organics, coated on like paint, and then dried, and it ends up being a PVDF polymer on the surface. The mold release agent is actually also a fluoropolymer. It's a fluorosulfonate polymer, usually dissolved in fluoroether. Fluoroethers are a liquid that have incredible uses, especially for cleaning your machine parts. Basically, any electroplated part you have is normally degreased of mineral oil after machining with a fluoroether. That one should be completely gone, and then it's electroplated. So that one is a manufacturing aid you should never see on your product. But if they switch away from fluoroethers, you're going to see quality issues on a lot of your electroplated parts, machine parts. So basically, all coated ones are that stay with the product, that don't evaporate or otherwise washed away, are all fluoropolymers. Very informative, thank you. Very appreciated, my pleasure. What's your comment on the proposed Belgian PFAS ban in single-use packaging? So individual countries can ban things in the EU if there's no harmonized standard, but if packaging is under the PFAS proposed regulation, there's not much they can do about it, because once it's harmonized, they have to follow the harmonized rules. What are the tests you recommend for detecting fluorine? Does SEM EDX work? Fluorine's very difficult to test for because of where it is in the periodic table. The most efficient test is WD XRF, especially if you've optimized it like ours. Ours is very, very good. It's a very good machine. Machines we use, you can't use ED or handheld XRF. It has to be WD, much higher power. You have to be very, very careful with how you prepare the sample, because even the thinnest film to hold it up or otherwise support it, which is common in a lot of XRF, will block fluorine measurement. Fluorine gets blocked by polypropylene, which is the normal, or mylar. They get blocked by that. So it's really WD-XRF is probably the best for surfaces. For pure concentration, it's combustion bomb. However, it is not as efficient. You can't do tons and tons and tons of parts a day. It's not as cost efficient as WD-XRF. It has some advantages in the combustion bomb for fluorine. Basically, it's you burn the whole thing to ash, and then you measure the fluorine in the ash by ion chromatography. Generally, WD-XRF is the best for the polymer side. If you want to do non-polymers, it's normally at the 25 parts per billion, it's liquid chromatography, tandem mass spec. Not all fluorine is PFAS. The thing is, fluorine very rarely exists not as part of a carbon. It's not a very naturally occurring substance. We can't think of any situation we've run into so far where the fluorine we've detected is not a fluoropolymer. It theoretically can be there separately, and in definitely medications there are non-PFAS fluorinated situations. But in physical products, we haven't seen a fluorine structure. It could be in a salt, but it'd be physically a salt, like a chemical. We haven't seen it in an article which it doesn't have all the aspects of fluoropolymer. Do you anticipate, as far as to exit the fluoropolymer market, do the new regs? Are you aware of drop-in replacements for fluoropolymer mold release agents? They're not as good. Silicone can do a lot of the same job, but there's many different reasons it is not as good. It can't handle oils, and it'll have a miserable time with polyurethane foam. 3M's exiting it, not because it isn't profitable, because it is quite profitable for them. It's legacy lawsuits related to their factories. But the business in general is growing quite strongly. The fluoropolymers are incredibly useful, especially in electric cars. I mean, you can't have an electric car battery without PVDF cathode right now. It's a very useful, harmless chemical. It's the most non-reactive probably chemical around. Very water resistant, which means acid resistant, very solvent, oil resistant. There's just a PFOA, because the movies and stuff like that has a pretty negative rap. And yes, PFOA in high concentration, like your laundry detergent. Your laundry detergent is 20 million times higher concentration than the PFOA in your Teflon part. You can do the same thing. Laundry detergent, if you ingest it, it will also cause your kidneys to not function properly. It screws up the protein surfactant in your kidneys that processes bacteria. Are you using ICP-MS or ICP-OAS for trace fluorine? No, we're actually using, using primarily WD-XRF. It's far more practical. When we have an inconclusive situation, like we have a very advanced process for detecting much lower levels, we use combustion bomb ion chromatography as the referee. It's not nearly as efficient, and it has trouble. It does the whole material instead of surfaces. It has trouble differentiating between one surface and another surface, but definitely we back it up with bomb chromatography. Combustion bomb ion chromatography. But the main one is WD-XRF. You need a high power machine, and you need to qualify it for low carbon. You need to handle fabrics. Fabrics are something else to test for fluorine because the way the side chain polymers are integrated into it. But if you really know what you're doing, it's incredibly useful, and you can just do so many samples quickly. It's far more efficient, especially from a cost and data perspective. We also back it up with an FTIR. The FTIR for higher concentration fluorine is excellent for identifying the fluoropolymer in play. Well, thanks again. I'm sorry I didn't get to everybody's questions. I'm going over time. And again, everybody will receive a copy of the slides. And thanks again to everybody who attended. And I look forward to talking to everyone again soon. And please reach out. We're really good at this. I mean, the worst case scenario, we tell you what we do and how much it costs, and you can tell us no, or just ghost us. We're not. I probably don't notice people who work with us for a while. We don't have salespeople contacting you regularly. It's not the way we do it. We focus our energy on the technical side. You reach out, you're not going to be contacted by a salesperson every week for the rest of your life. That's not going to happen. That's not the way we work. We're going to tell you what we're going to do and how much it'll cost. And if you like it, awesome. If you don't like it, you can tell us, or you can just ghost us. We don't take it badly, actually. We're really busy and we've got lots of good stuff on the go. We're pretty high volume here and really good at what we do. We're putting our effort into actually doing the best value for your money, not having a sales guy follow up every week. So if you contact us, don't worry about a sales guy now contact you for the rest of your known life. That doesn't happen to us. And thanks again, everybody, and talk to you again soon.